today, but still I am going to ask you once again, like how many engineers or like managers worked on performance engineering or profiling stuff before? Oh boy, I have a lot of work to do now. Okay, fine, no issues. I think after this meet, you will get to know what is actually profiling is and what actually is continuous profiling is. So, okay, myself I am Shaik Buden Saheb. I am working as part of observability engineering in Freshworks. So, let's imagine this situation. One fine Sunday, you are playing cricket or badminton with your friends, and a knock engineer or a on call you got saying that one of the customer is reporting that application is too slow for him. Now you have to rush to your home and open laptop, and you will open up your observability stack, some visualization on top of it. You see that metrics are saying that yes, for last 1 hour, that particular customer, whatever the page that he is opening, those particular API requests are taking time. That you understood from the metrics. Then you open logs, see if application logs or system logs are saying something about it. But logs also will not reveal anything other than the timestamps. Yes, that is taking time. Probably like each API request is taking 4 seconds or 5 seconds. Other than that, logs also might not show anything. Then you go to distributed tracing just to understand like any particular service is making any third party API call, that probably taking time. Like if I have microservice architecture like service A calling B and service B calling C, is B is taking time? Is that the culprit? You want to figure it out, so you open the distributed tracing. Even in such scenarios, distributed tracing also will not reveal anything. It just says that of course it is taking time, probably like your 95th percentile time is 9 seconds or 10 seconds. Now we are in Xylo, you can't do anything. Now you need to start guessworking. Immediately what you will check, any deployment happen in last 1 hour. You will check with your QA folks, you will report to your manager like there is some issue, we are checking it, but to be honest you don't know anything. You need to like do some trial and error methods. Maybe this is the issue, maybe my ggip compression is high, and what is the nature of the data that particular customer is doing, what is the exact operation, what is my request body, what is my response, all these things you will check, but it's entirely guesswork and experimental. You don't know exactly what is happening. Now imagine a system that exists which says what are your resources are consumed by which in your code, in your application code, what is the particular module, and in that module what is that particular class, and in that class what is that particular method, and in that method what is that particular line number that is consuming more CPU and more memory or more IO. That system is profiling for you. Yeah, hero introduction done. Poor guy, this guy never got real appreciation apart from logs, traces and metrics, but he is also worth the appreciation. So to be honest, profiling is not new in the observability space. Many performance engineers or SREs would have done at least one time in their entire career. But it has evolved much. Traditional profiling means in initial days, you will be setting up the entire application in your local system and you will do some load testing, but it's a local system, you can't perform much load testing on that, and you do some profiling. You will like logs, traces and metrics, you will be running some agents along with your application, right? Similarly, you will be running some profiling agent along with your application in your local, and you will generate some profile data, and then you need to figure out like whether this is working within our standards or not, like how much response time it is going to give, that you will guess. But production nature of the data and the scale of the data is definitely larger than your local system. So you can't make big out of the traditional profiling in your local. Then we move to, our industry moved to APM integrated profiling. That means like Neuralink, Dynatrace, Datadog, these guys also provide some profiling tools. But in production, nobody has dared to run that continuous profiling in their production systems, because the scale at which we get the request, and if you are continuously capturing what exactly your CPU is running or how exactly your JVM heap is behaving, that's really tough in production. So in APM scheduled profiling, you will like in my peak hours for 10 minutes run the profiling and give me the data. Then I will analyze it. but that is also not efficient, right? Within that 10 minutes data, you might not know what exactly happening with the application code. Then comes the continuous profiling. Now this guy has a very beautiful thing called as sampling, that you can control the frequency at which it is going to capture the profiles. You can tell the agent that every 10th millisecond go and capture what exactly my CPU is running, or you can tell like every 100th millisecond go and capture what is there in my JVM heap. Just capture it and tell it to me. So that let's say it is continuously capturing, and some customer mentioned that yesterday I created some entities in your application that got failed, or that is like very slow, it wasted my time, and you received that kind of support ticket. You can clearly come here today and open yesterday's profile and see that okay, for this particular customer, because of something like, for example, let's say he has more amount of users data and he is trying to export it into your application. Maybe the code that you have written is working for 100 users, he might be uploaded 1 million users, maybe you have not written that in batch wise. So after seeing that profile, that particular line of code clearly indicates that it is taking more CPU. So that you can immediately fix that by seeing that continuous profile data. So next onwards, when a large scale customer uploads some data to your application, it will not fail. Not only the profiling data, even the visualization of profiling also has lot of challenges. I will show you some example. For example, I generated like for 2 hours profile data, a simple Ruby application I have written. Just focus on this code. I have highlighted some sorting algorithm there. So I'm just calculating, like give me top 10 articles which are like engaging most. So I'm just checking on social shares, and it is like giving me top 10 sorted articles. This is a simple code, right? I'm running that in my application, and I ran the profiling also with this. If I directly go and see some call stacks that got generated from this data, no, it's not your eyesight, it is actually looking like this. Genuinely, the profile data looks like this when you see in a traditional way. And then industry moved to some other representation called as graphical representation. It's very small code, but you can see a mesh there. It's like looking like a transformer on a cable. So then industry moved to something called flame graphs. Thanks to Brendan Gregg, I think he was used to work in Netflix. He came up with this approach that we can represent this profiling data, all call hierarchy data, in something called flame graphs. So these flame graphs actually divide your entire screen into rows, where each row represents a method in your code. So if you see this, right, so basically it's a simple articles controller. It is giving me the top trending articles, 10 articles, and what it is saying is integer times. If you remember that, I have written a loop inside a loop. Basically, I am taking you into your computer science graduation course. This is just a bubble sort. That's what I am doing here, and it is taking time. So now I understand that, okay, this outer loop 2.69 hours it has taken out of my 4.76 CPU active time. And within the 2.69 hours, 1.33 hours has taken by inner loop. So this level of granularity continuous profiling is going to provide you, so that instead of doing a guesswork, you know the data. With the data, you can take insight, intelligent actions. So key characteristics of this continuous profiling is it's always on. It's not like customer reported issue, now you don't know what exactly happened with them, and now you go ahead and run profiling, that is of no use. So you need to continuously run this and identify if there is any bugs or issues reported by customers, or proactively if you want to optimize something to improve your performance, also that can be helpful. And with sampling, we don't need to worry about overhead that it is going to add our production systems. You can control it by like what we learned in Freshworks is, we can in production environments we are like little bit less frequent. So we are putting sampling like 100 milliseconds, go and capture for every 100 milliseconds, not like 10 milliseconds. But non-production environments where we have performance tasks or staging stacks. There we are having a very high frequency profiling agents running. So benefits, it's like, okay, in your local, if you are optimizing something, it might not look like very sophisticated thing, but if you picture it at large scale, let's say in your cluster you have 80 machines are running. With this continuous profiling proactively, you saw something that is taking time. For example, let's say you are using gzip compression, but you never thought about the compression rate at which I am compressing my objects. Let's say you are like ideal, you become idealistic and you are using very high compression ratio, and continuous profile shows that that particular gzip compression algorithm is taking more time. Then you realize it, and you don't need that much compression because that is too much aggression on the data compression, so you reduced a bit. Let's say that will take away lot of computation time from your CPU. So in your cloud, from that 80 clusters, in a cluster 80 machines, from 80 machines to, if you reduce it to 60 machines, by removing that compression rate or changing that compression rate to some slightly lesser, that can give you the amount of money from your cloud, like around 20 machines. Even I need to talk about developer experience also. That guesswork is very frustrating to developers. So they don't know what exactly happening. It's trial and error method. They can't, it's not in their local, right? It's a customer data and it's a production. So they can't do trial and error methods there. It's very risky. You need to get lot of permissions. So if you already know what exactly happening with these observability signals along with logs, metrics, traces data, if you know exactly why exactly it is also happening. And one more interesting point is logs, metrics, traces in such scenarios will tell you that this is the symptom. It's like you know the symptoms, but you don't know the underlying infection. So doctor also can't experiment with us. Let's give this dose of this medicine. Let's see if he reacts. He can't do like that, right? Developer also can't do like that. So if he knows beforehand what exactly happening with his resources of his system, he can fix it properly. Yeah. So if you want to start OpenTelemetry as a CNCF project, already building a profiling agent which is eBPF based, and Parka also contributing a lot to it, and Pyroscope guys which is acquired by Grafana. So this Pyroscope, Parka and OpenTelemetry collaboratively actually contributing a lot to these OpenTelemetry profiling agents, and you can start there. So we'll get to know all the details, or you can ping me on LinkedIn as well. Yeah, thank you. That's it I have.
Thank you so much, Shaik, for that introduction to profiling. How many of you all knew profiling already? Okay, so for most of you it was new today. Do we have any questions for him?
Yeah, I think so.
So, regarding this profiling, are we going to provide this profile agent because it comes